This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at area. And let's take a look at our first problem. This one's going to demonstrate some notation and what it all represents. Excuse me. Well, the instructions say find a sum, but this uppercase sigma, this E looking thing you see right here, means add them together. And this says that it's from k is equal to 3 to k is equal to 7. So what we're going to do is we're going to plug in first k is equal to 3, then we'll plug in k is equal to 4, k is equal to 5, k is equal to 6, and k is equal to 7. So for that's what that says. It goes by ones. It goes from 3 to 7. Now for the first one, k is equal to 3. We'll put 3 in for the k. So we're going to have 3 times 3 minus 2. For the k is equal to 4, we'll put 4 in for k. So we'll have 4 times 4 minus 2. We'll put 5 in for k. So we got 5 times 5 minus 2. Put the 6 in. We got 6 times 6 minus 2. And put the 7 in, we got 7 times 7 minus 2. Now this sigma means add them all together, so there's a plus between all these. Well, 3 minus 2 is 1, so we're going to have 3 times 1 plus 4 minus 2 is 2, so 4 times 2, plus 5, 5 minus 2 is 3, plus 6, 6 minus 2 is 4, plus 7, 7 minus 2 is 5. So that's going to give us 3, plus 4 times 2 is 8, plus 5 times 3 is 15, 6 times 4 is 24, 7 times 5 is 35. Let's see, that gives us 11 plus 39 plus 35. Let's see, what was that? 50, 85. Assuming I added correctly, didn't make any basic math error, your answer is 85 for that problem. Again, these first ones just kind of get you used to the notation. Our second problem says use sigma notation to write the sum. So we go ahead and write that down. 3 over 1 plus 2 plus 3 over 1 plus 3 plus 3 over 1 plus 4 plus dot 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 plus 3 over 1 plus 10. Okay, so we're going to have our sigma notation here. Now we look for things they have in common. Like all of these have 3 up on top. So we'll put a 3 up on top. And then they all start with 1 plus. From there, they kind of changes. Here's a 2, here's a 3, here's a 4. Dot, dot, dot means it keeps on going with that pattern up to 10. So it's going from 2 to 10. Well, that kind of implies this right here. K is equal to 2 to 10. And then we put K right here. And that'd be our answer. So again, you got to look for a pattern. Let's look at this example. We got n minus 1 over 3 plus n minus 2 over 4 plus n minus 3 over 5 plus dot 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 plus n minus 8 over 10. Okay, well, I noticed that all of these start with n minus. So we're going to have n minus here. Let's look at our number up on top. We got 1, 2, 3, all the way up to 8. So it looks like it goes from 1 to 8. So we're going to have k is equal 1 to 8. And then we'll have n minus, we'll put k up on top. Okay, let's look at our bottom part here. 3, 4, 5, up through 10. Now you can only have one sigma notation, and that's handled to the top. But let's look at this. 1 to 3, we added 2. 2 to 4, we added 2. 3 to 5, we added 2. 8 to 10, we added 2. So that's what we'll do here. This will be k plus 2. So you look for some kind of pattern to help you write it down. And that'd be your answer. Now you get Calc 2, and this gets kind of challenging to be able to spot these patterns. Now we got some summation formulas. Because if your n went up to 100, you wouldn't want to sit there and add up all those different items. So we need some other way to do it. What this says is we got the sum. We're finding the sum of from I equals 1 to n of c. C is a constant. And if that's true, then you just take your number times n. Our second one, we're finding the sum of I. That's equal to n times n plus 1 over 2. The sum of I squared is n times n plus 1 times 2n plus 1 over 6. And the sum of I to the third is n squared times n plus 1 squared over 4. Now we're going to use this with some of our basic properties of summation. And we'll show those by example. That's the way I like to do it. So let's take a look at our first one here. We got I equals 1 to 8 of negative 5. Well, that's this first one, where we see this is our C. And from the formula, the number up on top, this is our n, so n is 8. So this says that this adds up to C times n. So we're going to have negative 5 times n, which is 8. And that gives us negative 40. And that's our answer. So again, if you have a number, you're summing them up, you just take that number times n. Let's look at this one. I equals 1 to 10 of 3i minus 2. Well, some of our property says that if you got two different items in here, separated by pluses and minuses, then you can split them up into separate integrals, or separate summations, sorry. I equals 1 to 10 of 3i minus, from I is equal 1 to 10 of negative, or 2, because I put the negative out in front. So we split them up into two summations. Now I can take this 3. If you got numbers, you can take them and put them out in front of your summation symbol. So we got 3 times from the summation I equals 1 to 10 of I minus this. Okay, now these look like our formulas. Oops. Okay. Our first one, the I. Here's our formula for I. Now n is the numbers up there, so in this case our n is 10. And the formula says n times n plus 1 over 2. So the 3 stays there, and n is 10, so we're going to have 10 times 10 plus 1 over 2. So again, just plug my n into the formula. Minus, and we got the summation of a number. That's property 1. And we take the number times n. n is again 10, so we're going to take 2 times 10. Okay, so at this point, Now here we got 10 divided by 2 gives us 5, and 10 plus 1 is 11. Minus 2 times, actually I had 3 is only times that. Then 2 times 10 is 20. So we got 3 times 55 minus 20, which gives us 165 minus 20, which gives us 145. Assuming I didn't make any basic math error. So again, we split them into 2 separate pieces, broke it down so we could look it up on our formulas here. Here's I, and that's n times n plus 1 over 2, n times n plus 1 over 2. And this is a number, so you just take the number times n, so 2 times 10. Let me go ahead and save this. And let's look at our next problem. Okay, we got I equals 1 to 10 of I squared plus 3I plus 2. Well, our summation property says we can split this into separate summations. So summation from I equals 1 to 10 of I squared plus, and I'll put this 3 out in front, 3 times the summation of I is equal 1 to 10 of I, plus the summation from I equals 1 to 10 of 2. So again, we got our I squared, 3I, and 2. Split them into 3 separate summations, and then the 3 that's before the I put out in front of the summation. Let's look at our formulas for I squared. I squared is number 3, and we got n times n plus 1 times 2n plus 1 over 6. Now n is 10, so n, so 10, times n plus 1, 10 plus 1, and then 2n plus 1. So 2 times 10 plus 1, 2n plus 1, all over 6, plus 3's out in front of this, and then I. That's number 2. And we'll put 10 in for the n. So we got 10 times 10 plus 1 divided by 2. And again, whenever you have a number like this, you just take your number times n. So we'll take 2 times 10. Now always try to do a little bit of simplifying as you go along if you can. Like 10 and 6 are both divisible by 2. So that gives me 5 there, and I'll have 3 down here. 10 plus 1 is 11. 2 times 10 is 20, plus 1 is 21. Plus 3 times 10 divided by 2 is 5. Then 10 plus 1 is 11. Plus 2 times 10, which is 20. 21 and 3, or 21 divided by 3 is 7. So we got 5 times 11 times 7 plus 5 times 11 is 55 plus 20. So then we got 55 times 7 plus 165 plus 20. 538, 385, assuming I didn't make a basic math error. 165 plus 20 is 185, which gives us 570, I believe. Again, assuming no basic math error. Okay, let's take a look at our last one to show those formulas. Sum from I equals 1 to 5, I times I squared plus 3. Okay, let's go look at our formulas. They're pretty basic. You're either going to have a number, you're going to have an I squared, or I to the third. And you can have a number before I, or before I squared, or I to the third. You just can put it out in front of your sigma. Well, I got parentheses here. Well, that's easy. I'll go ahead and multiply the I through. So we got I is equal 1 to 5. I times I squared is I to the third. And I times 3 is 3I. Well, now we want to split this into separate summations. So we're going to have I is equal 1 to 5 of I to the third plus 3 times the sum of I equals 1 to 5 of I. Now notice this 3I, I put the 3 out in front of the summation. Now in all of these, the n is the number that's up on top, so n is 5. So let's look at I to the third. That's property 4. It says n squared. So we're going to have 5 squared times n plus 1. So we're going to have 5 plus 1 squared over 4. Plus 3 times, and then I is our second, which is n times n plus 1. So we're going to have 5 times 5 plus 1 over 2. Let's see, 5 squared is 25. 5 plus 1 is 6. 6 squared is 36 over 4. Plus 3. And then we got 5. 5 plus 1 is 6, so 5 times 6 over 2. Now 36 divided by 4 is 9, so that's 25 times 9, plus 3, and then 6 divided by 2 is 3, so we got 5 times 3 inside the parentheses here. Which gives us, what is that, 225? Let's see, 5, 4, yeah, 225. 5 times 3 is 15, times 3 is 45. Yeah. And add those, that gives us 6, 7, 270, assuming no basic math error. Which I'm pretty good at making those, so there might be at least one in this video somewhere. So I'm going to go ahead and save this. There we go. Now this next part starts talking about approximating the area of a region. So let's talk a little bit about that. So if we have a region here that we're working with, actually, let's try that again. Okay, if we have a region like that, and this will be A to B, and we're trying to find the area of this. Well, you could come up with the rectangles, where the right side of the rectangle is touching the graph, and if this width come up like this, come up like that, so we could put rectangles in here where we're touching the right side of the rectangle, or we could touch the left side of the rectangle, and then find the area of these rectangles and add them together, and that gives us approximately the area of this region. Now you could also always draw your rectangles so they're above the graph, and then you could also do it where they're below the graph. So there's different ways you can do this. Now, as we make these, of course, we got some error here. As you make these rectangles smaller, what you'll find is that your error will become less. And actually, as the number of rectangles goes to infinity, you'll find your error will go away. So that's what we're talking about here. Approximating the area of a plane region using right endpoints. And we got some steps here. And we got some steps here for the left endpoints. And we're going to look at an example to see how to use these steps. For me, just reading them, it's not going to mean a whole lot. Okay, so we got f of x is equal to 5 minus x from 1 to 5. And we got eight rectangles. And it says use left and right endpoints and a given number of rectangles. Find two approximations of the area of the region between the graph function and the x-axis over the given interval. Now this is assuming that our graph is above the x-axis. Let's look at the right endpoints first. So right endpoints. Step 1, find a number of rectangles. This is n. Well, they tell us 8 rectangles. N is equal to 8. Step 2, find a total width of the area. Total width is equal to your larger x value minus your smaller x value. Well, the larger is 5 minus the smaller, which is 1. So total width is 4. Find the width of each rectangle. W is equal to TW, which is 4. I'll try it again. Okay. W is equal to TW divided by number of rectangles. So TW divided by N. So we're going to have 4 divided by 8, which gives us 1/2. Find the offset. Offset is a smaller x value. So our offset here is going to equal to 1. Then we want to find the area using this formula here. Now right endpoints. Let's talk a little bit about that. Okay, so we're going from 1 to 5. So here's 1, 2, 3. Let's try it again. Okay, 1, 2, 3, 4. That should be a straight line, but you get the idea. 5. And we're looking at this graph right here. Well, we got 1 for offset. And then you see here it says find f of offset plus w times I. And I starts at 1. So we got 1 times our width, 1 times 1/2, plus our offset. So 1 times 1/2 is 1/2, plus our offset, which is 1. 1 plus 1/2 gives us 3/2. Well, 3/2 would be right here. Now, I'm not going to look at what this graph looks like. I'm just going to talk about this split up of this. Now, our next one. If I were to plug in I is equal to 2, you'd have 2 times your width. Our width is 1/2, so 2 times 1/2 gives us 2/2, or 1, plus our offset. Wait a minute. Offset is 1 plus width times I is equal to 2. So that's 1 plus. Oh yeah, 2. Okay. So that'd be right here. So we got a rectangle here. We got a rectangle here. And we're going to have 3/2, and we'll have 4/2. Now, I was demonstrating that with the summation, but it's a lot easier than that. If this is, if we're dealing with the width of 1/2, and you're starting here, then this is going to be a width of a half. This will be a width of a half. The next one will be 5 halves. Next one will be 6 halves, which is right there. Next one will be 7 halves, then 8 halves, and then 9 halves. So it increases by half each time. Now this is what happens when you split up this interval into 8 different rectangles. We got 1, 2, 3, 4, 5, 6, 7, 8. And this is based upon our right endpoints. Now let's go ahead and take a look at this formula right here now. Scroll down a little bit. There we go. So the area is going to equal to the summation of I equals 1 to n, and f of our offset plus our width times I times our width. Okay, so we got I is equal 1 to n. F of our offset was 1. That's from step 4 here. This is step 5, by the way. Plus W. W is 1/2 times I. Now I changes each time, so we can't actually plug it in. Times our width, which is 1/2. Now this handles itself. You don't necessarily need to come up with these values up here. I was just demonstrating what in the world are we doing. This 1/2 goes out in front of your summation. You can freely take numbers in and out, so we don't want to worry about that one. And now we got f of 1 plus 1/2 I. Well, let's take a look at our function. Our function was 5 minus x. So we're going to have 5 minus, and then this is what we're going to put in for x. So we've got 1 plus 1/2 I. So again, this is evaluating a function. I took this 1 plus 1/2 I and put it in for my x in my original function. Now I'll do a little bit of simplifying. That minus flips the sign of everything, so it becomes a -1 minus 1/2 I. Five minus 1 is 4. So we've got 4 minus 1/2 I. Now we don't want to do this the hard way, so we're going to use our formulas. Now remember what n is. N is going to be our number of rectangles, which is 8. So we're going to have, but I leave the 1/2 clear out in front, and we're going to have I equals 1 to 8 of 4 minus 1/2 summation I equals 1 to 8 of I. So again, I just split that up. Put the 4 in a separate summation, and the minus 1/2 I put out in front of the other summation, just had an I here. Okay. Back up to our formulas. If we just got a number here, remember you take the number times n. So we'll take 4 times 8 minus 1/2 and I. That's our second one. So where the n is, we're going to plug in the 8. So we'll have 8 times 8 plus 1 divided by 2. I'm about out of room here. 1/2, 4 times 8 is 32, minus 2 times 2 is 4 down in the denominator. 8 divided by 4 is 2. 8 plus 1 is 9. 2 times 9 is 18. Now let me double check that. That's 4, 2 times 9, 18. Okay, yeah. 32 minus 18 is 14 times a half gives us 7. And that's using our right endpoints. Now let's look at our left endpoints. Okay, our left endpoints. Find a number of rectangles. This is n. So n is equal to 8. Find total width of the area. Larger x value minus smaller x value. Well, TW is equal to 5 minus 1, which is still 4. A lot of this doesn't change. 3. Find the width of each rectangle. W is equal to TW divided by n. Well, TW is 4, divided by n, which is 8, which gives us 1/2. Step 4, find the offset. Offset is equal to your smaller x value, which was 1. And now we're ready for step 5. Find the area. Okay, so we're going to have our area equals the summation from I equals 1 to n of f of offset plus w times I minus 1 times w. Well, if we plug in what we're given, we got I is equal 1 to n, f of our offset, which was 1, plus w, which was 1/2, times I minus 1, times w, which is 1/2. Now again, whenever you have a number like that, you can just put the number out in front, so you don't need to worry about it. Then I equals 1 to n, and just to make sure I have enough room, I won't show all the steps here. But 1/2 times I is 1/2 I. 1/2 times negative 1 is negative 1/2. Plus 1 gives us a positive 1/2. Now we want to take that and plug that into our function, because this is f of this. Our function, if you remember, was 5 minus x. So we're going to have 5 minus 1/2 I plus 1/2. And I can do a little bit of simplifying on that. So we got 1/2 I equals 1 to n. That gives us negative 1/2 I. Negative 1/2, 5 minus 1/2. This is 10 over 2, that's 9/2. Like that. We'll split them into separate summations. So we're going to have negative 1/2 summation I equals 1, and n was 8 of I, plus the summation from I equals 1 to 8 of 9/2. So again, to split this into two separate summations. And the negative 1/2 that's in front of our I put it in the negative 1/2 in front of our summation. So we're going to have 1/2, negative 1/2, and our formula for I, number 2, we got n times n plus 1 over 2. N is 8, so we have 8 times 8 plus 1 over 2, plus, and remember, if you have a number, summation of a number, you take that number times your n. So we'll have 9/2 times 8. Okay. Well, let's have to reduce a few steps here. 2 times 2 is 4. 8 divided by 4 is 2. So we got negative 2 times 9, which gives us negative 18. Plus 8 divided by 2 is 4. 4 times 9 is 36. Okay. 36 minus 18 is 18, times a half is 9. Okay. Now, when we find this, find the left and the right, what we'll find is the area is somewhere in the middle. So it's a pretty good guess, since we came up with 7 here and 9 here, our guess would be that the area is 8. I don't think they ask us to do that in these problems, but let me see for sure. Use left and right to find 2 approximations of the area. So they just want us to find approximations. Now, if I were to show this on the calculator, we haven't covered this yet in this course, but if I go to y equals, press clear, put in 5 minus x. I'm going to press the zoom and choose Z standard, number 6, like this. Now if I do second trace, the 7th one here, the one with the integration symbol, if I choose that, it'll ask me for my lower limit, and we'll put 1, and then our upper limit's 5, because this goes from 1 to 5. So do 1 enter, 5 enter. And you see it comes up and tells me it's equal to 8. So that's actually our area. You know, here's an approximation below the actual area. Here's one that was above it, and then again, halfway in the middle. I shouldn't say it's not always halfway in the middle. It depends upon what problem, but you can see 8's in between them anyway. So let me go ahead and save that. Go. And let me find another example. This one right here. Now this one we'll have to kind of do it brute force. We won't be able to do the same thing we did the last one. And 8 rectangles. Okay, how can I look at this? No, I can't use what I did last time. Well, if we go up, these are our formulas. Very basic. You either have a number, you have I squared, or I to the third. If you don't have those, then you just have to straight plug it in, which we'll see. Okay, let's go to our right endpoints. Okay, so our first step, find the number of rectangles. They tell us there's 8 rectangles, so n is 8. Our second step, find the total width of the area, larger x value minus smaller x value. So we'll have TW is equal to pi minus 0, which gives us pi. Step 3, find your width. Width is equal to TW divided by n. So TW is pi over n, which is 8. 4, find our offset. Offset is equal to smaller, which is 0. And now we want to find this. So, number 5. I equals 1 to n, which was 8 in this problem, and f of our offset, which was 0, plus w, and where's w? But w is pi over 8 I times w, which was pi over 8. Okay. Well, this pi over 8 that's at the very end can go to the very beginning. We can take it out in front of our summation, so we don't have to worry about it. And then we've got I equals 1 to 8. And 0 drops away, and we just got f of pi over 8I. So we're going to take that pi over 8I and put it into our function. So we're going to have sine of pi 8I. Now we're going to go through and plug in I equals 1, I equals 2, I equals 3, and so forth. So we're going to have sine, if I plug in I equals 1, 1 times pi over 8 is pi over 8, plus sine, if I plug in I equals 2, we're going to have 2 pi over 8, plus, and if I plug in 3, again, I keeps increasing by 1. We'll have 3 times pi over 8, which is 3 pi over 8. And you probably see a pattern here, don't you? This will be sine of 4 pi over 8 plus sine of 5 pi over 8 plus sine of 6 pi over 8 plus sine of 7 pi over 8. And it goes all the way up to I equals 1 to 8. So it goes up to 8. So we're going to have plus sine of 8 pi over 8. Now there's probably not a whole lot of benefit to finding the exact value of some of these, because you can't find the exact value of all of them. So if you're going to plug it, part of it in your calculator, might as well just plug all of it in there. So let me go here. I want to make sure I'm in radians. So I'll press mode, and I'm in radians. If you're not in radians, down arrow to that line. Make sure your flashing cursor's on radians and press enter one time. And I'll do second mode. I'll press clear a couple times, clear that screen. And we're going to have pi over 8. So second caret divided by 8. Beginning parentheses, sine of pi over 8. So sine of pi divided by 8. Close parentheses plus sine of 2 pi divided by 8 plus sine of 3 pi divided by 8 plus sine of 4 pi divided by 8 plus sine of 5 pi. Be a miracle if I don't screw this up. Plus sine of 6 pi over 8 plus sine of 7 pi over 8 plus sine of 8 pi over 8. Okay, let me check all that. Sine of pi over 8 plus that's 2 pi, 3 pi, plus 4 pi, plus sine 5 pi, plus sine 6 pi, sine, okay, blah, 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 blah. Okay, enter. And that's going to give us 1.9742. Okay, well let's do the left endpoints and see what we come up with. Okay, left endpoints. Step 1, find a number of rectangles. So n is still 8. TW, larger x value minus smaller x value, total width. Still the same, excuse me. Pi minus 0 is pi. 3, our width is going to equal to TW over n. TW is pi over n, which is 8. And our offset is still 0. Okay, now here's where it changes. Step 5. Our area is going to be I is equal 1 to 8. F of our offset, so 0 plus W. W is pi over 8 times I minus 1 times W, which was pi over 8. Okay. Now, I'm going to take that pi over 8 and put it out in front. And then we're left with I equals 1 to 8. We're left with this right here. Now, if I go ahead and plug that in to my function, I got sine of x. Now, put this in for x. So I got pi over 8 times I minus 1. It's probably best not to actually multiply it through, because you'll see a pattern a lot easier if you don't multiply it through. Okay, so this is going to be pi over 8 times sine. Now I starts at 1. If I put 1 in for I get 1 minus 1, which is 0, so you get 0 pi over 8. Plus sine, and if I put in I equals 2, 2 minus 1 is 1, 1 times pi over 8 is 1 pi over 8. Plus sine, and if I put in 1, 2, 3, 3 minus 1 is 2, I get sine of 2 pi over 8. You see the pattern? 0 pi over 8, 1 pi over 8, plus 2 pi over 8. So we're going to have plus sine of 3 pi over 8, plus sine of 4 pi over 8, plus sine of 5 pi over 8, plus sine of 6 pi over 8, plus, now if I put in my last one, goes from I equals 1 to 8. If I put 8 in for I, 8 minus 1 is 7, we get 7 pi over 8. So our last one is actually going to be the sine of 7 pi over 8. Like that. And we'll plug that in to our calculator and see what we get. I might be able to cheat here a little bit. Maybe. Let's see if I do second enter to bring up the previous entry. And our first one here, this is 0 pi over 8. 0 times pi is 0. 0 divided by 8 is 0. Sine of 0 is 0. So that doesn't matter. So it's actually starting at sine of 1 pi over 8, which is sine of pi over 8, my first one here. And then it's going to have all of these except for the very last one. So it stops at sine of 7 pi over 8. And now press enter. And we get 1.9742. Now you can see our right endpoint, our left endpoint, see how they give us the same value to 4 decimal places. So it's a pretty good assumption for approximation that our area is going to be 1.9742. Now we could plug this into our calculator again. Sine x. You should still already be in radians from what we did earlier, but if I press y equals, clear, sine x. Now we're going to go from 0 to pi, so I'm going to do a zoom and choose number 7, z trig. That'll set it from negative 2 pi to positive 2 pi. And then I'm going to do a second trace and choose number 7. Lower limit is 0, upper limit is pi, so I'll do second caret, enter, and we get 2. Again, these are just approximations. So I'm kind of surprised on that. Oh yeah, because sine of 8 pi over 8 is pi, which gives you that. But I'm kind of surprised that the actual value isn't somewhere in between those. That's kind of weird. But anyway, we're finding approximations. Unless I made a basic math error somewhere. I wouldn't rule that out. But main thing is you get the idea. Okay. Let's see, that was number 9. So let's come down to here. Now these are very closely related. This is approximating the upper sum for a region using the right endpoints, and approximating the lower sum for a region using the left endpoints. And you'll find that the formula is exactly the same as what we're doing. They just got a little bit of different notation, and specifically we're talking about the sums. Adding rectangles below and above, so forth. In class, I oftentimes don't even show an example of this, but I thought for the video I think I'll show one. So let's take a look at this one. Let's see, number 10. Got f of x is equal to 2 over x. It's from 1 to 2. And we got 4 rectangles. And it says use upper and lower sums to approximate the area of the region using a given number of subintervals of equal width. Oh, by the way, on this one that wasn't exact here, if we took more rectangles, you'd find approximation gets better. Okay, so let's look at the upper sum. Step 1. I don't have in here find n, but that's because with this, I assumed that after you'd done those earlier ones that I shouldn't even probably have to put all of this, but that still goes without saying. N is 4. They tell us 4 rectangles. Okay, so our TW is larger x value minus smaller, which would be 2 minus 1, which gives us 1. And number 2, W is equal to TW divided by N. So that's 1 divided by N, which was 4. So W is equal to 1/4. 3, find the offset. It's a smaller x value. So offset is equal to 1. And now we're ready to find our upper sum. And it's represented by uppercase S. Next one will be a lowercase s, the lower sum. Okay, so this says we've got the sum of I equals 1 to n, which n was 4. F of the offset was 1, plus W is 1/4 times I, so 1/4 I, times W, which was 1/4. So again, just plug in everything we're given there. Now, as always, we can put that 1/4 out in front. So we've got 1/4 like that. I equals 1 to 4. F of this. Well, this is evaluating a function. We're going to plug this in for x. Because this is f of x, so we're going to plug that in for x. Well, we got 2 over x, so we're going to have 2 over 1 plus 1/4 I. Probably if I simplify that a little bit, it'll probably help. Guessing. Okay. Since I made this problem up and I haven't actually worked it. But if we get rid of the fraction within the fraction, so we multiply everything by 4. Multiply the 2 by 4, and we get 8. The 1 by 4, and we get 4, plus, and multiply the 1/4 by 4, and that disappears, and we got I. Now, we don't have any formula for this. There's no way we can write this in terms of I squared, I to the third, or a constant. So we're going to have to work with it as is. Now, to begin with, I can take this 8 and put it out in front. So we're going to have 1/4 times 8. And now we're going to go from I equals 1 to I equals 4. So we'll plug in, the 8's gone. So we've got 1 over 4 plus 1. This is I equals 1. Plus 1 over 4 plus 2. This is I equals 2. Plus 1 over 4 plus 3. That's I equals 3. Plus 1 over 4 plus 4. And that's I equals 4. Okay, 1/4 times 8 is 2. And that gives us 1/5 plus 1/6 plus 1/7 plus 1/8. And I'm going to go ahead and plug that in my calculator. These are approximations, so decimal's fine. Usually in Calc 1 we don't like decimals, but it's, what am I doing here? Okay, 2 beginning parentheses, 1/5, so 1 divided by 5, plus 1 divided by 6, plus 1 divided by 7, plus 1 divided by 8. Now I'll take it to 4 decimal places again. And that gives us 1.2690. And that's our upper sum. Well, let's find our lower sum. Keep in mind this is an approximation. 4 rectangles isn't very many, so I don't know how close it would actually be. Upper sum, so lower sum. And n is still 4. So let's look at our steps on that. Let me grab a drink here first. Okay. Step number 1. TW, total width. Larger x value minus smaller. 2 minus 1 equals 1. Step 2. Find the width of each rectangle. So width is equal to TW divided by n. So we got 1 divided by n, which was 4. So they're 1/4. Step 3. Find our offset. It's a smaller x value, which I think was 1. Then step 4. Find our lower sum. That's little s of n. And then that's going to be the sum from I equals 1 to n, which was 4. F of the offset, which is 1, plus w, plus 1/4, times I minus 1, times, then w at the end, so that'd be 1/4. I'm going to take that 1/4 and put it out in front, so we don't have to worry about it. And it's probably to your benefit if we don't simplify this. Just guessing. But we want to plug this in to our function. So if I go up above, our function, remember, was 2 over x. 2 over x. So we're going to plug what I underlined in red in for x. So we're going to have the sum I equals 1 to 4 of 2 over 1 plus 1/4 I minus 1. Now we want to get rid of the fraction within the fraction. So we can multiply everything by 4, multiply 2 by 4 and we get 8. Multiply the 1 by 4 and we get 4. Multiply the 1/4 by 4 and that gives us 1 times I minus 1, which is just I minus 1. So we're multiplying everything by 4. Now that 8 I can put out in front again. So that gives us 1/4 times 8. And then I equals 1 to 4 of 1 over I. 4 minus 1 gives us 3. So I plus 3. Okay, 1/4 times 8 is 2. And now we'll plug these in. We'll plug in I equals 1 first. We'll put 1 in for I. So we've got 1 over 1 plus 3. Plus, then we'll put 2 in for I. So we've got 1 over 2 plus 3. We'll put in 3 for I. So we've got 3 plus 3. Plus, and we'll put in 4 for I. So we've got 4 plus 3. So it's going to give us 2 times 1/4 plus 1/5 plus 1/6 plus 1/7. And let's see what that gives us. So 2, 2, and then beginning parentheses, 1/4. So 1 divided by 4 plus 1 divided by 5 plus 1 divided by 6 plus 1 divided by 7, enter. And we get 1.5190. Still bothers me in that previous one we didn't get a value in between it, but oh well. Now if I actually found the true value of this, I go to y equals clear 2 divided by x, press zoom, choose 6, and then we'll do second trace and choose number 7, and we're looking between 1 and 2, so do 1 enter, 2 enter, 1.3863, 1.38. See, and it's between these two values, which is what you'd expect. That's why I think I made a math error on that last one, but oh well. That's how to find your upper sum and lower sum. So I'm going to go ahead and save that. Someday I'll take time to re-record it and correct my error. But when I do that, I'll probably put another error in there, so the truth of the matter is I probably won't ever record it again. If I went off of a script, I wouldn't make any errors, but then there'd be no fun for me and I wouldn't do it. Okay. Now this is how to find the area by the limit definition. And we're going to look at an example to show these steps. Just reading the steps doesn't mean a whole lot. So let's look at this one. Got y is equal to 5x plus 1 from 0 to 6. Now they say use the limit process to find the area of the region between the graph of the function and the x-axis of the given interval. It says sketch region. I'm going to use a calculator, and I'm going to use a calculator to kind of check myself to see if I came up with the right answer. Okay, so let's go back to our steps here. Finding area by the limit definition. Step number 1. Find the total width of the area. TW is equal to larger x value minus your smaller x value. So that's going to be 6 minus 0, which gives us 6. Step 2, find the offset. Offset is your smaller x value. So your offset is going to equal to 0. Step 3, find the area using this formula. So we got the area is equal to the limit as n goes to infinity. And then we got the sum of I equals 1 to n. Now it truly is n here. It's not like 4 rectangles or 8 rectangles. We're looking at an infinite number of rectangles. And then we're taking this, which is the height, times the width. So we got f of our offset. We said our offset was 0 plus TW. TW we said was 6 over n times I. Times TW over n. TW is 6 over n. Now keep in mind what changes in this. As we're going through this, I changes. First I is equal to 1, then I is equal to 2, then I is equal to 3, and on up until I is equal to infinity. Because we're studying it as limit as n goes to infinity. So the 6 over n doesn't change. So I can put that 6 over n out in front of our sigma. So I got limit as n goes to infinity of 6 over n, then the summation I equals 1 to n of f of 6i over n. The 0 drops away. Now this is evaluating a function. So we're going to plug this in for x into our function. So we'll have the limit as n goes to infinity of 6 over n, and limit as I is equal 1 to n, and we're plugging in 6i over n in for x. So we got 5 times 6i over n plus 1. Okay, so that's going to give us limit as n goes to infinity of 6 over n. And we're going to split this into separate integrals. Why do I keep saying integrals? Separate summations. So we got I is equal 1 to n of, this would be 30 over ni, plus, then the summation from I equals 1 to n of 1. So again, 5 times 6 is 30, so that's our 30 over ni, and then the 1. I just split them into two separate summations. Well, then, we've got limit as n goes to infinity of 6 over n. Now this 30 over n is, again, it doesn't change. I is the only thing that changes. So the 30 over n I can put out in front of this summation. So we've got 30 over n, summation from I equals 1 to n of I, plus this summation from I equals 1 to n of 1. Now these should look familiar. I'll learn to speak someday. These go back to our formulas here. So let me carry this down. So limit as n goes to infinity of 6 over n. And then we got 30 over n times, and this matches exactly. See how the I equals 1 to n of I? I equals 1 to n of I. So this is going to be exactly what you see here. So we're going to have n times n plus 1 over 2. Now here, this is a number, and that's our first property. We said if you have a number, you take the number times n. So we'll take 1 times n, like that. Okay, let's do a little bit of simplifying. So we've got limit as n goes to infinity of 6 over n. The n here and n here cancel. The 2 and 30, this becomes 1, and this becomes 15. So we're going to have, let's see, 15 times n plus 1 plus 1 times n is n. Let me double check myself here. Okay. So we got limit as n goes to infinity of 6 over n. 15 times n is 15n plus n is 16n. Plus 15 times 1 is 15. Which, this 6 here I could put clear out in front of our limit, because it's a constant. And then I'm going to put this is 1 over n, so I'll have 16n over n plus 15 over n. Again, when we take the 6 out in front, that leaves us 1 over n. So I just took 1 over n times 16n and 1 over n times 15. Which gives us, those n's cancel, and I got 16 plus 15 over n. And now we can plug in infinity for the n. You can at least think of it that way. We're actually studying the limit, but this would be 15 over infinity. And remember, if you have a number over infinity, that always goes to 0. So this becomes 6 times 16 plus 0, which gives us 96, assuming I didn't make a basic math error somewhere. Now let's double check me on this. I'll come up here, y is equal to 5x plus 1. So I'll go to our calculator, press y equals clear 5x plus 1. Do a second trace. Choose number 7. Then we're going to go from 0 to 6. So 0 inner, 6 inner. And you see we get 96. So doesn't look like I made any kind of math error on that one. Let me go ahead and save that. And let's look at our next one. Back down. Okay, we just did that one, so let's take a look at this one. And you can tell this is kind of a tedious process. You wouldn't want to do this all the time. Which a couple lessons from now we'll see an easier way. Okay, so wanting to find this. Of course, obviously, you look at the calculator, it's like, well, it don't get any easier than that. Let me go ahead and get a drink here. And let's work this problem. Okay, find the area by the limit definition. First step, find total width of the area. TW is larger x value minus your smaller. So we'll have 5 minus 1, which gives us 4. Step 2, find the offset. Offset is your smaller one, which is 1. Now step 3, find our area. It's going to equal to the limit as n goes to infinity of summation I equals 1 to n f of the offset, which was 1, plus TW, which is 4, over n I, times TW over n. So 4 over n. Now again, the 4 over n, the only part changes in your summation is your I. So I can take that and put it out in front. Can't put it clear out in front, but we can put it out in front of the summation. And then we got I equals 1 to n of this. And it's probably easier to just go ahead and plug that in for x now. So we got 1 plus 4 over ni squared plus 3. Because it was x squared plus 3. So that gives us limit as n goes to infinity of 4 over n. Our summation I equals 1 to n of 1 plus 4 over ni times 1 plus 4 over ni plus 3. Now this 4 I can put clear out in front, so I don't have to worry about it. So we got limit as n goes to infinity of 1 over n, and then I equals 1 to n. 1 times 1 is 1. 1 times 4 over ni gives us 4 over ni. 4 over ni times 1 gives us 4 over ni. 4 over ni times 4 over ni gives us 16 n squared I squared plus 3. Well, this is going to give us 4 out in front. Limit as n goes to infinity of 1 over n. Summation from I equals 1 to n. 1 plus 3 is 4, plus 4i over n plus 4i over n is 8i over n, plus 16 n squared I squared. Now we want to split these up into separate summations. Okay. So we're going to have the summation of 4. So I equals 1 to n of 4 plus, and then the summation of 8i over n, but the 8 over n I can put out in front. So we've got 8 over n, the summation I equals 1 to n of I. Then this last one, I can put the 16 over n squared out in front. Basically, when you're working these problems, the number here is the exception. But if you got i's or I squared or I to the thirds, whatever else is with the I or I squared, you can always put out in front of your summation. Okay, so then we've got 4 limit as n goes to infinity of 1 over n. Now remember, if you have the summation of a number, you take the number times n. So we're going to have 4 times n plus 8 over n. I almost remember this one. N times n plus 1 over 2, I think. Let's see. I. That's our second one. N times n plus 1 over 2 plus 16 over n squared times I squared. I squared was our third one, which is n times n plus 1 times 2n plus 1 over 6. Okay, now we have to do some simplifying. So we've got 4 limit as n goes to infinity of 1 over n. This will become 4n. Now this n and this n cancel. 8 divided by 2. That goes to 1, and this goes to 4. So we're going to have 4 times n and 4 times 1. Now over this other one here. Let's see, the n squared and n, that goes no n there, and then this just leaves us a single n here. 16 and 6 are both divisible by 2, so that gives us 8, and this one gives us 3. So let's write down what we have left. We have 8 times n plus 1 times 2n plus 1 over 3 times n. Okay. So we've got 4. I'm running out of room. Limit. So 4n plus 4n is 8n plus 4 plus, and I'll do this over on the sides just because I am running, or am I running out of room? I still have a room. Never mind. Go and see now. N times 2n is 2n squared. N times 1 is n. 1 times 2n is 2n. 1 times 1 is 1 over 3n. Now I could go ahead and multiply this 1 over n through. So we've got 4, the limit as n goes to infinity. So I'm going to have 8n over n plus 4 over n plus, and then I'm going to put this n downstairs here, and we've got 3n squared. And up on top, we got 8 times 2n squared is 16n squared. N plus 2n is 3n, times 8 is 24n. And then 8 times 1 gives us 8. Like that. And we can do a little bit of more simplifying. Here, those n's cancel. We got 8 plus 4 over n plus, and I can split these into separate fractions. So I have 16n squared over 3n squared plus 24n over 3n squared plus 8 over 3n squared. And a little bit more simplifying. That gives us 8 plus 4 over n. These n squareds cancel, and we got 16 over 3 plus one of these n's cancel, and 24 divided by 3 is 8, so we got 8 over n plus 8 over 3n squared. Well, now we're ready to plug in our infinity. So we got 8 plus 4 over infinity plus 16 thirds plus 8 over infinity plus 8 over 3 times infinity squared. Now all those that have infinity down in the denominator are going to go to 0, so they're going to disappear. So we have 4 times 8 plus 16 thirds. Okay, so 4 and beginning parentheses 8. I'm being lazy here. 16 divided by 3, close parentheses, math, inner. And we got 160 over 3. Now let's see what that is approximation-wise. So 160 divided by 3, 53.333, whatever. Time to check to see if I made a math error. And it's almost guaranteed I'll make a math error in one of these. These I'm not that great at for doing without screwing up in some way. But press y equals, press clear, x squared plus 3. Now I'll do second trace, choose number 7, and this is going to go from 1 to 5. So I'll do 1 inner, 5 inner. Ah, that looks good. 53.3333. So that looks like I came up with the right answer. No math errors. So let me go ahead and save this. I still have one problem to possibly screw up. Not that I feel really good about that one where it came out the same value. I think it was the trig one, sine or cosine or whatever it was. There we go. So let's look at our last problem. Okay, just did that one. Let's take a look at this one. So we've got y is equal to 3x plus x to the third and 0 to 1. When it doesn't have an offset, it's actually a little bit easier. So even though this one looks a little bit harder, I think it'll be easier because it starts at 0. Okay, step 1. Find total width of the area. Total width is going to be 1 minus 0, largest x value minus your smallest, which gives us 1. Step 2. Find the offset. That's your smaller x value, which will be 0. Okay, then step 3. Find area. So our area is equal to the limit as n goes to infinity, the summation of I equals 1 to n of f of our offset, which is 0, plus tw over n, so 1 over n I times tw over n, so 1 over n. Well, again, now 1 over n we can put out in front of the summation, so we got limit as n goes to infinity of 1 over n, and I equals 1 to n. Now the 0 drops away, and we got f of 1 over ni. So we'll put the 1 over ni in for x. So we're going to have 3 times 1 over ni plus 1 over ni to the third power. Again, this is just evaluating a function. So we're putting this right in here in everywhere we have an x. Okay, so we got limit as n goes to infinity of 1 over n, I equals 1 to n. This is going to give us 3 over ni plus 1 to the third power is 1, n to the third power is n to the third, and I to the third power is I to the third. Go away fast. Okay, now I want to split these into separate summations. So I'm going to have the summation. Try it again. I'm going to have 3 over n, and then the summation from I equals 1 to n of I. Now remember, everything except for the I squared, I to the third, you can just put out in front of the summation. So the 3 over n, I just put out in front of the summation symbol. Plus 1 over n to the third, the summation from I equals 1 to n of I to the third. Again, everything except for the I to the power you can put out in front, like that. And now let's look these up in our formulas. So we got limit as n goes to infinity of 1 over n. 3 over n, I almost remember this. No memory. Okay. For second formula, I is equal to n times n plus 1 over 2. Plus 1 over n to the third power times I to the third, which is our fourth one here, which gives us n squared, n plus 1 squared, all over 4. Okay, do a little bit of simplifying. This n here will cancel with that n. This n squared will cancel with two of the 3 here, so it leaves us an n down here. So we got limit as n goes to infinity of 1 over n. And this will be 3 times n plus 1 over 2 plus n plus 1 squared over 4n. That's what we have left after we canceled. Now I can multiply this 1 over n through. So I got limit as n goes to infinity of 3n plus 3 over 2n. I multiplied the 3 through. 3 times n is 3n, 3 times 1 is 3. And then n times 2 gives us a 2n there. Plus n plus 1 times n plus 1 over n times 4n, it gives us 4n squared. Okay, so limit as n goes to infinity, and split this into separate fractions. So this would be 3n over 2n plus 3 over 2n plus n times n is n squared, n times 1 is 1n, 1 times n is 1n, 1 times 1 is 1 over 4n squared. So we got limit as n goes to infinity. These n's cancel, and we got 3 halves plus 3 over 2n plus, and I'm going to split these in separate fractions, n squared over 4n squared. 1n plus 1n is 2n, so we got 2n over 4n squared plus 1 over 4n squared. So we got limit as n goes to infinity, 3 halves plus 3 over 2n. These n squareds cancel, and we've got 1/4 plus 2/4 becomes 1/2. And we got n over n squared, so that just gives us an n downstairs, plus 1 over 4n squared. Well, now we're ready to plug our infinity in for n. So we got 3 halves plus 3 over 2 times infinity plus 1/4 plus 1 over 2 times infinity. We're not actually plugging it in, we're studying it as it goes to infinity, but basically whenever you have a number up on top and infinity downstairs, then it goes to 0. So this ends up giving us 3 halves plus 1/4. All the rest of these went to 0. Which this gives us, what is that, 6/4, 7/4? And if my brain wasn't shutting down, I could tell you easily what decimal is. I have no clue. 7 divided by 4. 1.75. Okay, so let's use the calculator and see if I made a math error. So press our y equals, clear. We'll put our function up there, 3x plus x to the third. 3x plus x to the third, and then do a second trace. Choose number 7, the integration one. Lower limit is 0. Enter. Upper limit is 1. Enter. And we get 1.75. Hard to believe, but I didn't make any math error, at least in that part. Maybe earlier on I did, but not in that problem. So I'm going to go ahead and save that problem. There we go. And that was the last problem in that PowerPoint, I think. Yeah, it was. So I'm going to go ahead and save the video.